An electrolytic cell containing cobalt-2 chloride solution and lead electrodes is assembled. The notation for the cell is as follows. Part A. Predict the reactions at the cathode and anode and in the overall cell. So just like a voltaic cell, we list our species and we identify our SOA, that will be our cathode, our SRA, that will be our anode. Then, like before, from page 7, from the table, we have the reduction half reaction of cobalt plus 2 electrons gives me cobalt solid. We have the oxidation half reaction. We have lead solid turning into lead 2 ions and losing 2 electrons. And then we have our net redox, just like before. Now, draw and label a cell diagram for this electrolytic cell, including the power supply. So the technique here is to treat this as if we were doing a voltaic cell. Don't change anything until the very end. Treat this as a real voltaic cell. Once we've finished with our voltaic cell, our electrolytic cell only differs by the changing of the signs on the electrode. So notice here that I've scratched off the negative and the positive and replaced them with the opposite sign. Between the voltaic and the electrolytic cells, everything is the same except for the signs on the electrodes. Notice all labels and arrows are the same as voltaic cells except the signs on the electrodes. So do everything like a voltaic cell and at the end switch the signs on the electrodes. Don't change any arrows or labels. The last part of the question asks us, what is the minimum voltage that must be applied to make this cell work? So knowing our cathode and our anode, from page 7, do not change the voltage that you find on that table. The standard of the cell, the E cell, is the cathode minus the anode. Don't change the signs, just follow the equation. So in this case, we have negative 0.28 volts minus negative 0.13 volts, giving us a value of negative 0.15. Notice that the value is negative, meaning that this reaction is non-spontaneous. As a result, we must provide a power source of 0.15 volts minimum must be pumped to make the reaction happen. Hope that helps.